Okay, this is the display project I've been working on. Here's the display. I've tapped into basically just the 16 pins coming off the LCD, and I am using a Arduino and support circuitry to basically give this very cheap scale an RS-232 out. These signals are raw LCD signals. These are not. This is not just like D0 to D7. This is raw LCD signals. They're all AC. There's 4 voltage levels. So the process is difficult, but I've worked through it. And as you see in the upper right-hand corner, our weight value, and I'll just slowly start adding some weights to the scale. We'll see it come up. So there's a little bit of delay in the updates. As you can see, it's missing the first digit, but it'll pop up. There it goes. So it'll do that for other digits sometimes. That's some glitch in the firmware. Not really sure what that is, but I'll figure it out eventually. So it's not really necessary for the project we're working on to update the weights in real time like this. And as I'm talking, I'm just adding small weights to show that we've got an accurate reading on the screen. So it works pretty good. Yep, so yeah, I'm just using the Arduino. It's an Atmel IC, very cheap, about $3, with the Arduino bootloader. Here I have this is just a PIC microcontroller. This is necessary to generate the timing signals. I have to have this. I tried generating them in the excuse me, in the Arduino, and it just would not work. You have to have an accurate clock to do what I'm doing, and you'll see that when we get to the scope here in a second. So this here is a 4051 multiplexer. I actually just robbed this from a Liberty CPU that wasn't working. Here is this is just an AND gate that's used in the clock development. This is just an FTDI that I'll eventually use to get the serial out. What you're seeing there on the screen is just that's just the serial out from the Arduino IDE. Okay, so let's go over the scope. Alright, so what you're seeing here, the bottom signal, this yellow one, this is the back plane. This is coming off pin 1 of the display. This signal never changes. The purple signal, you'll see it change. This is the raw data for the number 1 digit, the place 1 digit. So that's 0, that's 1, and this will flick back and forth between 0 and 1. So what I want you to notice about the back plane here is I've got a 0 volt, 1 volt, 2 volt, 0 volt, 1 volt, and here we have a 3 volt. So I'm running this signal through the CMOS AND gate, and this is the output. So it gives me basically a steady timing signal that I use to figure out what bits are what here in the actual data that we want. Now it's too wide for me to use as is. It's the same width as these bits, 2 milliseconds. So I'm running this signal here into the PIC, and this is the output of the PIC, which is a 500 microsecond. So this allows me to get right in the middle of our signal there, or close enough to the middle, so I can take an accurate reading. So this signal it's 8 bits wide, and it's just repeating. So what I'm doing here is when this goes high, I'm taking the reading, I'm delaying about 4.5 milliseconds, taking a reading, delaying, taking a reading, delaying, taking a reading, and that gives me a unique 4-bit data point that I load into an array, and that's basically how I'm getting the data off that display and formatting it in a way that a computer can understand. So, yep, there it is. Works works good. I'm happy with the progress so far.